All right, so this is 8.3 day 2, which the directions say it's the dot product, but that's because that's what it's called in the textbook. But what we're talking about today is whether two vectors are orthogonal, parallel, and then we're also going to do decomposing a vector into two orthogonal vectors. All right, so let's go ahead and get started. It says recall the formula for the angle between two vectors. Okay, so this formula we did already learn, and if I wanted to find that angle theta right there, I do the cosine of theta is equal to, I take the dot product of the two vectors, so v dot w, and then I divide it by the magnitude of each vector multiplied. So magnitude of vector v, or w, I didn't have to erase that, times the magnitude of vector w. And then to find the angle, you would use cosine inverse of whatever that is. All right, so it says, now consider the special case where the two vectors are perpendicular and using that formula above. So think about this. If these two vectors are perpendicular, we know what theta is already. We know theta is 90 degrees. So let's go ahead and replace theta with 90 degrees. So we have cosine of 90 degrees is equal to the dot product divided by the two magnitudes multiplied. I did it again. Okay, so how is this different? We know the cosine of 90 degrees. So cosine of 90 degrees we know from the unit circle. So let's think about what that is. 90 degrees is right here. That's the ordered pair 0, 1. And the cosine is 0. So we get 0 is equal to, I'm copying and pasting because I'm not going to keep writing this 500 times. Copy, paste. We get 0 is equal to this. And now remember, in order for a fraction to be equal to 0, the numerator has to just be equal to 0. The denominator can't be equal to 0, but the numerator has to be equal to 0. Another way of thinking about this is that if I said, all right, now start to solve this equation, and you cross multiply by putting this over 1 and then cross multiplying, you get 1 times the dot product, which is the dot product, is equal to 0 times this, which is 0. Okay? So I want that circle to go away. All right, so 0. So in other words, if we know that angle is 90 degrees, the dot product is 0. Or in other words, if the dot product is 0, we know the angle between the two vectors is 0. We know the angle between the two vectors is 90 degrees. In other words, if two vectors form a 90-degree angle, they are perpendicular, okay? What we say instead of perpendicular is the word orthogonal. So orthogonal means perpendicular. So right here it says orthogonal, which means perpendicular, which you could also call normal vectors. So we know two vectors are orthogonal if their dot product is 0. So if dot product is 0, then the vectors are perpendicular, or orthogonal is what we use. The vectors are orthogonal. Okay, another way that we know that the vectors are orthogonal is if we look at the slopes. So if the slopes of the vectors are opposite reciprocals, then they're perpendicular. Oops. Let's not say perpendicular. Let's say orthogonal. Keep doing it. Okay? I'll show you how to do that second part when we get to examples that ask us about it. Okay, what about vectors being parallel? So it says for this situation, determine what all four vectors have in common. Well, I totally gave that away. If you look, they are not the same length. They are not the same direction, but they all are parallel. So how are the components AI plus BJ of these vectors related? So how are they related? All right. What you can do if you have the vector, so this will also help you with this in a moment. If you know the vectors, you know what all of them are. What you can do is you can take the ratio of B over A, that ratio of B over A, and that will give you the slope, okay? If the slope is the same or proportional, then the vectors are parallel. So I'm going to say then parallel. All right, so it says now, so that's one way. And then now let's consider the special case where the vectors are parallel using the formula at the top of the page. How could we tell if the vectors are parallel? So what we first need to know, like we knew that if these are perpendicular, this was 90 degrees. If the vectors are parallel, the angle in between them is either 180 degrees or 0 degrees. So let's write that down because I think it's important to write that down. If vectors are parallel, sorry, my alarm, the angle between them is 0, between them is 0 degrees or 180 degrees. So we're going to have to do both. We're going to have to say theta is 0 degrees and theta is 180 degrees. All right, so let's write our two equations. We have cosine of theta, well, not theta, we'll do cosine of 0 degrees is equal to, and then that formula, which hopefully, yes, still pasted. And then we also have cosine of 180 degrees is equal to that angle formula there. There we go. Yay. Okay. Just like the perpendicular one, we can replace cosine of 0 degrees and cosine of 180 degrees. So let's think about what those are. Let's use our unit circles. 0 degrees is right here. 180 degrees is right here. 0 degrees, this is the ordered pair 1, 0. 180, ordered pair negative 1, 0. So the cosine's 1 here and the cosine's negative 1 here. So if we get 1 equals, copy and paste this, or negative 1 equals this, paste, sorry, then we know that the vectors are parallel. So basically, what we're going to have to do to see if the vectors are parallel is that we do the dot product divided by the two magnitudes multiplied. If you get it's equal to 1, or if you get it's equal to negative 1, then the two vectors are parallel. So let's write that in here. If v dot w divided by the magnitude of v times the magnitude of w is equal to 1, or v dot w divided by the magnitude of v times the magnitude of w is equal to negative 1, then the vectors are parallel. Okay? All right, also if the slopes are the same. If the slopes are the same, then they're parallel too. Once again, you can do that by doing b over a. Okay? All right, let's get into some examples. We're only going to do 2 because they're easy. Easy. The steps are easy. You know how to do all of them. All right, I'll do A, and then you can pause the video and try B on your own. Determine if each pair of vectors is parallel, orthogonal, or neither, using the dot product angle formula. So we are using that formula, cosine of theta equals the dot product divided by the magnitude times the magnitude. Then it says confirm using slope. So after we're done, then we'll do the slope and see if what we got is true. Okay, so we're using cosine of theta equals the dot product. So I need the dot product. So I'm going to do v dot w. And you may have noticed that we're putting arrows above these. It's because vectors can be named with arrows, and we want you to see it with and without. All right. So the A value is multiplied, 6 times negative 3, plus the B value is multiplied, negative 2 times 1. Get that number. So that's negative 18 minus 2, which is negative 20. So the dot product is negative 20. And then I need the magnitude of V. And I also am going to need the magnitude of W. All right, so square root of A squared plus B squared. So 6 squared plus negative 2 squared. The square root of 36 plus 4 is 40. I'm just going to leave it. And if you're like, wait, you can simplify that to 2 root 10. I'm going to end up throwing it in my calculator. So no need. All right. Oh, I almost forgot to say this because it's obvious. I just got the dot product as negative 20, not 0, so I already know orthogonal's out, all right? I already know orthogonal's out, so really I'm checking to see if they're parallel, and if they're not, then it's neither. All right, so I got the square root of negative 3 squared plus 1 squared. All right, so that's 9 plus 1, so I got the square root of 10. Okay, so now I'm going to see if v dot w divided by the magnitude of v times the magnitude of w. I need to see if it's 1 or negative 1, because if it is, they're parallel. If not, then they're not. All right, so what I'm doing is negative 20 divided by root 40 times root 10. I'm going to put that in my calculator. Now, I'm looking at it. I don't need a calculator, but you can use one. If you look at it, the reason I don't need a calculator is because I know root 40 times root 10 is root 400, and root 400 is 20. Negative 20 divided by 20 is negative 1. So I know that these are parallel because that's negative 1. But just in case you need a calculator, negative 20 divided by root 40, get out of the square root, root 10, get out of the square root. Oops, I didn't get out of the square root. Get out of the square root, close the parentheses, hit enter, negative 1, like I said. All right, so since that is negative 1, I know that these are parallel. All right, now let's do the other one, and then we'll use the slope formulas too. Well, then we'll show it using slope. Okay, so dot product first, v dot w. So I have 4 times 3 plus negative 2 times 6. That's 12 minus 12, which is 0. This one's done. The dot product 0. These are orthogonal. Okay? All right, now we're going to confirm using slope. So we are going to find the slope of v first. So I'm going to put the slope of vector v is, this is a, this is b. We're going to do b over a. Negative 2 over 6, which is negative 1/3. So the slope of v is negative 1/3. Then we're going to do the slope of vector w, which is, this is a, b is 1, so 1 over negative 3, which is negative 1/3. The slopes are the same, so they are parallel, confirmed. And you might be saying, like, why can't we just do that? Because the first part says using the dot product angle formula. All right, let's try this next one. The slope of v is, this is a, this is b, negative 2 over 4, which is negative 1/2. And this is a, this is b. Slope of w is 6 over 3, which is 2. These are opposite reciprocals, right? Opposite reciprocals, orthogonal. Check, we're right. Okay, last thing that we are going to talk about on these notes, and if you look at my notes key, they are longer than this. There is another topic after this, but I made the decision that we're not going to do that. So this next topic we are doing, which is decomposing a vector into 2 orthogonal vectors. Okay, so basically what you're going to have here is you're going to have an object on a ramp and it's moving down the ramp. Okay, so it says consider an object on an inclined ramp. Here's your object, here's your ramp right here. Okay, the force F due to gravity is pushing the object down the ramp. Okay, so gravity is this piece right here. This vector, I shouldn't say piece. This vector right here, that's your gravity, which F. So the force F is due to gravity is pushing the object down the ramp. So down the ramp is F1. So this is F1 right here. And then it's also against the ramp, which is right here against the ramp. That's F2. What you should notice about F1 and F2 is that they're orthogonal. So F1 and F2 are orthogonal. And the vector F1 is parallel to the ramp. So notice F1 is parallel to the ramp. Also, ramp is going to, I'm going to call a vector W, okay? The reason I'm calling it vector W is because in the formula, instead of F's, they use V's. So it's V1, V1, V2, and this is V, okay? All right, so If you have two vectors, v and w, okay, so if you're like, what vectors are you talking about? There's so many letters going on right now. This is w, and this is v right here. Okay, so you have the force, and then you have the ramp. The decomposition of v into two vectors, v1 and v2, where v1 is parallel to the ramp, and into w, which is the ramp, and v2 is orthogonal to the ramp, which is w. So this is v1, this is v2. What we're going to do is we're going to break it down into v1 and v2. So this is how you find v1, okay? So to find v1, what you're going to do is you're going to have two vectors, v and w. You are going to take the dot product of the two vectors, v and w, and you're going to divide it by the dot product of w in itself. Then you're going to multiply that by the vector w, okay? And I can put arrows above all of these, but I feel like the arrows make it look scarier, but it's okay. All right, then you're going to find v2. To find v2, you take the original vector v, and you're going to subtract the v1 vector that you just got. And the reason why is because v1 plus v2 is equal to v. So if you solve that for v2, you get v minus v1. Also, v1 is called the projection of v onto w, just so we're aware of that vocabulary. All right, so there's two problems here once again. We can do example 3 together, and you can pause and try example 4 and check to see how you did. All right, so this is what the problems look like all the time. The words don't change. So if you can follow the process, you'll be fine. Decompose vector v into two vectors, v1 and v2, where v1 is parallel to w and v2 is orthogonal to w. And then it gives us the vector v, and it gives us the vector w. So we have to find v1 first. Okay, the formula is right above, but once again, what you're going to do is you have to do the dot product of v and w for the numerator here. So I have 4 times negative 3 plus 2 times negative 1. In the denominator, you're going to do the dot product of w and w. So negative 3 times itself, which is negative 3, plus negative 1 times itself, which is negative 1. Then you're going to get that, it's going to be a number, and you're going to multiply it by vector w, which is negative 3i minus j. So you're going to distribute whatever that number is into that. All right, so let's get this cleaned up here. Negative 4 times 3 is negative 12, plus negative 2 over 9 plus 1 times negative 3i minus j. And you don't want to overuse your calculator because you don't want to turn this into a decimal. You still want it to be a fraction. So I have negative 14 over 10 times negative 3i minus j. But negative 14 over 10 is simplifiable. They're both even, so 2 goes into both. Negative 7/5 times negative 3i minus j. All right, now I need to distribute, and I'll have vector v1. All right, so I'm going to put v1 equals. All right, remember, this is just 3 over 1, and this is 1 over 1. So I have positive 21/5 I. Negative times a negative is a positive 7/5 j. Positive 21/5 I plus positive 7/5 j. That's v1. So like if you look at the actual process, it's not difficult, but just making sure you know the formulas, I guess, is the difficult part. To find v2, if you look at the formula once again, you take the original vector v and subtract v1. So the original vector v is right here, 4i plus 2j. And you're going to subtract, now remember, it's two terms, so you have to subtract the whole thing. 21/5 I plus 7/5 j. All right, so now we have to subtract these two, so I'm going to distribute my negative. So this is plus, minus, minus. And then I got to combine like terms. I got to combine 4i and negative 21/5 I. 21/5 I. I need a common denominator for that, so I'm going to put this over 1. That becomes 5. So this is a 5. Multiply this by 5, multiply this by 5. So that's 20/5 I and negative 21/5 I, which is negative 1/5 I. Then I'm going to do the same thing for j. I need a common denominator, put this over 1, multiply by 5, multiply by 5. So that's 10/5 j minus 7/5 j. And I did minus because it's negative right here. Same thing with this one. So that's 3/5 j. And those are your two vectors, v1 and v2. Working with fractions is not everyone's favorite, but that's the hard part. All right, if you want to pause the video and try one on your own, you can. And then I will show you how to do it. All right, so v1 dot product of the two vectors, so -2 times 4 plus 1 times 3, divided by the dot product of w in itself, 4 times 4 plus 3 times 3. Multiply that by vector w, 4I plus 3j. All right, so let's get this all cleaned up here. So that's -8 plus 3, which is -5. And you can do the mental math or you can use your calculator for help, but just don't put the whole thing in your calculator, right? You can do this in your calculator first because you could have used a calculator. -8 plus 3, which is -5, over 16 plus 9. So 16 plus 9, 25. 4I plus 3j. -5 over 25 is simplifiable to -1/5 times 4I plus 3j. And then distribute. So v1 equals, remember this is over 1 over 1, -4/5 I minus 3/5 j. And there is your vector v1. All right, almost done. Just got to get my vector v2. Take the original vector v, -2I plus j, and subtract, this is a binomial, -4/5 I minus 3/5 j. All right, we all know I'm not a big fan of subtraction. I'm going to distribute my negative, plus, plus, plus. Combine like terms. In order to do that, I need a common denominator, so I'm going to put this over 1. And the denominator is 5 again. Not because it's always 5, just so we realize that. So I have -10/5 I plus 4/5 I. So that's going to be -6/5 I. All right, and then this is common denominator. This is 1 over 1. Multiply by 5, multiply by 5. So that's 5 over 5. That doesn't look like a 5 over 5. I plus 3/5 I. Sorry, j and j. Wow, I messed up this, this, and this. This is I, and this is j, and this is j. So that is 8/5 j. And that's v2. All right, so that is it for today's notes.